And now I just want to talk about what we're doing this week. So there's two important concepts this week, and everything is building on nomenclature. Like all the things that we've learned before, sig figs, the math rules, using units, those things all still apply. So this week, we're going to focus on mole ratios.
Can you share your screen, Sue?
I don't know. I think so. Let me try. So a mole ratio is going to be important for this idea, which is lab this week, called an empirical formula. And I'm going to run through one example, and then tomorrow you'll see the pages. And the other idea is called percent composition. So empirical formula is the idea of, we might have a certain number of grams of iron and grams of oxygen, and our goal is to figure out what the ratio of oxygen to iron is. And we know that iron could be iron 2 or iron 3, so that it could be 2 to 3 or 1 to 1. And so it's a way of using mole ratios to come up with a formula that reflects what is actually there. I'll do a problem like that in a second. And then percent composition is just saying, well, how many grams of iron are in a certain number of grams of iron, in this case, iron 3 oxide, times 100%. And so those are the two important ideas this week. And I'm going to pull up a question, or pull up a problem and work through a question. Here I have a key. I'm just going to walk through it. So let's say that you were told, and I'm looking at, you all can see this problem, right?
Yes.
Okay. So let's say I was told that there is a cobalt sulfide, formed when cobalt is combined with sulfur. And so cobalt and sulfur are mixed, and we could either have cobalt 2 sulfide or cobalt 3 sulfide, because cobalt has 2 charged states. So a student reacts some grams of cobalt, that's reflected down here, 0.565 grams of cobalt, with sulfur, and they come up with this many grams of product. So the idea is separate your masses into each of the elements. And so I know that I have 0.565 grams of cobalt, because that's what I started with. And then the amount of sulfur that combined was 0.462 grams. And I know that because I subtracted. And then we use the molar mass. So here I have the molar mass for cobalt to figure out how many moles of cobalt are present in that sample. And I use the molar mass for sulfur as it appears on the periodic table, not S8, to figure out how many moles of sulfur I have. And then I'm dividing by the smaller number in green to come up with the ratio of sulfur to cobalt in this compound. Okay, I'm about to hide that screen and then work through the problem. So these are the important problems, important points of something called an empirical formula problem. Empirical just means we did something in the lab and came up with this experimentally. So experimentally, what is the formula? And so we started with some grams of an element, and then we ended up through experimentation, which we can't do, but Rhiannon will do a video and show you how she did this. Some grams of a compound. And if we subtract the cobalt out of the cobalt sulfide, we end up with just grams of sulfur. And that's what we have here. Now, I've told you in the past that sulfur like this on the periodic table is just S, but nonmetals to become stable have 2 ways to do that. And one is to gain electrons, and one is to share electrons. And sulfur can share electrons with itself, and we call that the element, or it can share electrons with another element, a nonmetal or metalloid, and that makes a compound. But the point is that how we see it on the periodic table is not stable. How it exists in nature is a way that it is stable enough to exist. Sometimes that's ionic and sometimes that's covalent. And in this case, it's going to be ionic. So even though I'm writing S here, in my mind, I'm thinking sulfide. So I'm just going to do atoms of sulfur. Understand that adding 2 electrons doesn't change the mass very much. Okay, and then we go through a process where we change the grams of cobalt to moles of cobalt, and the grams of sulfur to moles of sulfur, and then we make a ratio. So once I have my moles of each element separately and in a monatomic form, 1 atom form, I look to see which number is larger. And this is 0.009, and this is only 1 0. So this is the larger number. And then I divide the larger number by the smaller number. So it's not like I always divide the metal by the non-metal or anything like that. I'm going to divide the larger number by the smaller number. So this is me thinking, what is the ratio? It's 0.0144, and I'm not rounding anything. I'm keeping as many digits as I can. Moles of sulfur divided by 0.009586 moles of cobalt. And then I divide it on my calculator and get a ratio. And I'm looking for it to look like a whole number or a fraction I recognize. This fraction looks like 1.5. I want to have complete units, so I remember that my numerator is moles of sulfur and my denominator is moles of cobalt. And the moles can't cancel because they're moles of different things. So what I've got so far for my formula, because it's ionic, I put the metal first, cobalt comes first and sulfur comes second. And the number for cobalt is 1, and the number for sulfur is 1.5. Oops. And I can't have a ratio. I don't have formulas that have fractions. So I need this to be whole numbers. The formula unit for an ionic compound is the lowest whole number ratio of cations to anions. So what I need to do is take this ratio that I came up with, 1.5 moles of sulfur for every 1 mole of cobalt, and multiply it by 1 in the form that brings it to whole numbers. So I can multiply anything by 1. I'm going to multiply this by 2/2. And when I do that, 1.5 times 2 is 3 moles of sulfur. 1 times 2 is 2 moles of cobalt. And now I have the ratio for the formula. There's 2 cobalt atoms for every 3 sulfur atoms. This must be cobalt 3. If there are any questions, I am ready for this. And if you don't know what your questions are, it's because this is their first time maybe looking at this, and this is what we're going to do this week, and by the end of the week, you'll be fine with it. But if you have questions, please let me know. Okay, to highlight the main points, an empirical formula is a formula that we come up for a compound empirically, which means in the lab. And the first step in solving the problem is to get the kinds of elements, the masses of them by themselves, and then convert the masses into moles of atoms. So even though sulfur might exist as a polyatomic element, in this case it's really sulfide, or it's really atom by atom. We're going to look at it by atoms. And then once we end up with the moles of the atoms, we get a molar ratio. And then we use that molar ratio to come up with a formula, and there will be a section to read and problems to practice and examples in a video and a lab that will help you do that. Okay, that's one idea this week. The other idea this week is percent compositions. For percent composition, we're just looking at something that has, it's some compound and has more than one element. And we could say, well, how much of one element, kind of element, in the whole? And we would come up with a ratio. And then if we multiply that ratio by 100%, we call it a percent. And it's the composition of the formula. And because we're going to be looking at grams of one element divided by grams of everything, we call it a mass percent. So the second thing we're going to do this week is come up with mass percents. And these are much more straightforward. So the first thing we need is a compound. And I might have a compound like nitrogen dioxide. And so the whole is going to be nitrogen dioxide. Oops. And the one element is either nitrogen or oxygen. Somebody will pick. So I could pick oxygen or nitrogen. And we're going to do this because it's going to be a mass percent. We're going to do it in grams. So I look on my periodic table and I say, if I had 1 mole of nitrogen dioxide, how many grams of nitrogen would I have? And how many grams of everything would I have? So for nitrogen, I would have 14.01 grams. There'd be 1 mole of nitrogen and 1 mole of nitrogen dioxide. And then for the grams of everything, I just need the molar mass. If I had been asked instead what the percent composition of oxygen was, there's 2 ways I can do it. The first way is I would start with oxygen on the top. So we have 2 moles of oxygen at 16.00 grams per mole. And we have 1 mole of the compound at 46.01 grams per mole. And let's multiply that by 100%. So the reason I'm doing this extra, what looks like an extra little bit by multiplying them by the moles, is to recognize this 2 means there's 2 moles of oxygen. I have to double that 16. I need to have 32 divided by the everything. And if I've done things correctly, if I add the percent that is nitrogen and the percent that is oxygen, it should add to 100% because those are the only 2 elements in the compound. And I got 99.99, so I'm close enough. So I can do it by just taking what's in the numerator is 1 element, and what's in the denominator is everything, and I multiply it by 100%. Or I could have said, well, if I know that 30.44% is nitrogen, 100 minus that is oxygen. Because if there's only 2 things, they have to add up to 100%. So 100% is nitrogen plus oxygen. And if 30.44% is nitrogen, and I subtract them, The difference is oxygen. Alrighty, that's all I got. Add up.
I literally lost an entire inch when I was pregnant with my daughter, and somehow I gained it back. I grew it back. So, yeah.
Wow. Okay, that sounds like the arches.
Yeah.
That's amazing.
Courtney, I'm gonna I probably send you a picture of the boys. So this was 10 years ago, but so every December we would go to the Galleria. Like we go to the mall one time a year just to watch people, and we would get hot cocoa and sit on the benches and
The best.
you know, gawk. Yeah. And I have a picture of the boys. We went into Eddie Bauer, and they put on hats. They're such goofballs. So I will definitely send you that picture, but maybe I'll get one this weekend. I'll send you also.
Yeah, you should do that. I don't know where you're going, but in my dream that I had about you, you were climbing into the passenger side of a dark colored truck, like an extended cab truck, and you were on your way to do something, and it was nighttime outside. So I don't know if that happens while you're down there. You'll have to be like, Courtney, you're weird, but
You're prescient, yeah. So Redondo Beach, we're going down. They live in Long Beach and Glendale. I thought you were here at the beginning. I think I was talking about that.
Yeah.
If I climb into a truck on a dark night, I'll let you know.
All right. Well, I hope you enjoy your time with your boys, and happy birthday.
Thank you so much.
I'll be looking forward to that picture.
Okay. It's great having you all in class. Thanks for staying around and chatting and being human.
I'm just nervous about the test. This is me procrastinating.
Take the practice tests. You got 5 of them.
I know, which makes me nervous because there's 5 options, which means the practice test doesn't reflect really. And I've taken
it's the same it's the same questions.
Yeah.
Like it's all very
I've done moles before. This is not brand new information for me. I should not be this nervous.
But you do need to do the practice test so that you can enter it correctly, because the formula problems have to be entered with a lot of zeros.
Okay. All right. I'm gonna
Bye, guys.
do it. Okay. Bye. Thank you.